want to be at Solander Point by August because it's interesting geologically. It has more dissection where we might be able to see these very fine laminated rocks that may have more of these clay minerals, and maybe the breccias overlying them. But we want to get there by August also because we're approaching the winter on Mars. We're in the southern hemisphere. In the winter, the sun is toward the north, so we need to be on north-facing slopes. And Solander Point has beautiful north-facing slopes, 15 to 20 degrees. So that's the kind of broad context. And we're beelining it across Botany Bay, which in itself is interesting because it has a lot of rock exposure. But we want to get to Solander Point with enough time to kind of look around and figure out where we want to focus our winter campaign that's coming up. If we go to Arvidson 2, that's kind of one of my favorite views because that's showing the last image that we took of the southwestern edge of Cape York on this bench that surrounds these rocks. And you can see kind of rocks that dip. We should be on the next graphic after this. We see rocks that dip away from Cape York. That's the bench, and probably represents the oldest sedimentary rocks that formed when the ejecta of Cape York and whatever pre-existing bedrock that makes up Cape York and Endeavor's Rim, we're being covered by sedimentary material much later than the formation. And in fact, Botany Bay is covered by these younger sedimentary rocks called the Burns Formation. So you can see in the Arvidson 2 graphic that basically the bench rocks are dipping, away from Cape York, and they're being covered by these younger Burns Formation sedimentary rocks, basically sulfate sandstones from this more acidic period that Steve mentioned. So we're after the early period. We're after Solander Point. And what we want to do is go to the third graphic, Arvidson 3, and that's just a beautiful view taken on Sol 3,325 or thereabouts, where we looked at Solander Point and we took it in color. It's false color in that it's, green kind of, it's blue, it's green, it's a little bit of red and infrared, and it's stretched so you can see the colors. But the beauty here is you can see multiple layers. So we're hoping, this stratigraphy that we've been backing out and the interesting chemistry and mineralogy, particularly of the lower stratigraphy, where we think we have clay minerals in Cape York, they should be exposed in Sutherland Point, maybe in those bright layers. And maybe we can see the contact, the geologic contact between those older rocks that could be pre-existing rocks, ancient rocks, and just uplifted by the Endeavor impact event, and then the breccias superimposed. It all remains to be seen. But we'll be there along about August, and we'll have time to explore and then settle in and probably occupy a number of winter campaign sites over the Mars winter. And the reason is that there's a lot of stratigraphy exposed, and the slopes are beautiful. They're 15 degrees or about, so you can catch a lot of sun tilting the vehicle and the solar panels in that direction. So you can see Botany Bay, and then you can see the bench that surrounds Solander Point, and finally you can see these multiple strata. And the relief at Solander Point is a beautiful 55 meters from the tippy top down to Botany Bay. So there's a lot to explore there. It's in effect, as John said, a whole new mission, yet again, coming in on the 10th anniversary. So with that, let me turn it back to James so we can get to the question and answer session.
Thank you, Ray and Steve and John. And, we're going to start the Q&A. And, again, if you do have a question for the reporters out there, please press *1, and you'll give your name and your affiliation to the operator so we can put you in the queue. Our first question today is going to come from Ken Chang at the New York Times. Morning, Ken, or good afternoon.
Great, thank you.
Ken, can you speak up a little bit? You're sounding real low there.
Sorry. Yes, this is with Steve. So last December at AGU, you were describing some light-colored, fine-grained rocks on Jekmatijevic Hill that you said you thought were full of clays. I was wondering what came of that, and how does that compare with what's in Esperance that you also think has clays in them?
Yeah, okay, good question, Ken. The identification of clay minerals, recognize there are many different kinds of clays. The identification of the clay minerals that we reported on at AGU was not even really made by our rover. It was made from orbit by the CRISM spectrometer on Mars Reconnaissance Orbiter. It suggested a very low concentration of clays, maybe a few percent clays in these rocks that make up a substantial portion of Matijevic Hill. And what we found, and this is some really nice work that was done by Ray actually, was we found that if you match up the orbital signature with the rocks on the ground, you find a very, very good correlation. So we concluded that these rocks on the ground, these fine-grained rocks that we found, did have a small concentration of clays. What's different about Esperance, and this is dramatically different, is that this is a place that's a very narrow zone. It's, as I tried to stress earlier, it's a place where water flowed through the rocks, probably along a fracture. And the concentration of clay minerals here must be much, much, much higher than it is anywhere else at Matijevic Hill. If you took those rocks that we reported on back at AGU and you plotted them on that triangle diagram, they would plot right down next to the average Martian crust stuff. They're really very, very similar chemically. And so while they've had a little bit of clay produced in them somehow, right at the surface of them at least, it's a very, very different situation from what we see with Esperance.
Yeah, and just to add to that, Steve and Ken, the clay minerals we think we have over Whitewater Lake, largely from the chrism detection, it's a different kind of clay mineral. It's called a smectite. It's an iron-magnesium-rich clay. And on Earth, it's the first thing that forms when you slightly alter or wet basalt. And you have a basaltic composition, and you just produce a little bit of these iron-magnesium smectites. If you alter it a great deal more, with a lot more water fluxing through, then you produce a more luminous clay, which is the montmorillonite. So the trend that Steve showed is entirely consistent with a little bit of alteration for Whitewater Lake to produce smectites, and then within the fracture, a greater flux of water to take the composition all the way to this luminous montmorillonite.
All right. And our next question is going to come from Dan Vergano at USA Today.
Hey, folks. Thanks for doing this. I wanted to ask, how does this evidence for more neutral pH water at this site sort of play with the finding of similar kind of more neutral pH minerals at Gale Crater with Curiosity? And the second part of the question would be, like, what sort of picture of the broader geology of Meridani Planum are you getting from the sort of difference in clays that you're seeing here?
Okay, sure. I can take that one. It's really striking to me how similar are the stories that are being told by the rocks that were recently investigated by Opportunity at Endeavour Crater, and the rocks that have been recently investigated by Curiosity at Gale Crater. Now, these are again very, very new results. They have to be interpreted with caution. But I mean, recognize that the Curiosity landing site was chosen. The basis for choosing that was the exciting possibility that clay minerals would be found there. And the whole reason that we did this 3-year-long trek to Endeavour with Opportunity was because the orbital data told us we might find clays there. So it's paid off beautifully. It's paid off on both sides of the planet almost simultaneously. As far as the broader picture of what this tells us about Meridiani Planum, what it tells us that conditions changed over time. Esperance, Matijevic Hill, these rocks are the oldest rocks ever looked at by Opportunity. And what they're telling us is that there was an early period in which clay minerals were forming under kind of a neutral pH, and then subsequently the chemistry of the water changed. It changed to a more acid condition that produced the sulfate-rich rocks that we see over most of the Meridiani region. And the interesting thing is that this is broadly consistent with patterns that you see over the whole planet. There's a lot of evidence that suggests that in the earliest rocks, the oldest rocks on Mars, you have minerals that tend to be more consistent with a neutral pH. And then planet-wide, as conditions changed over time and the water conditions changed to a more acidic pH, you began to produce different mineralogy, particularly sulfates.
And I think
Go ahead, Steve.
No, this is Dan. I was just going to ask how old you guys.
Oh, Dan,
I've been trying for 10 years now, man.
Okay, I wish. This is the problem that always bedevils us when we talk about old and young on Mars, is that I can talk about older and younger because I know this stuff is buried beneath all that other stuff. So it's older. But in terms of absolute ages, I really don't want to hazard a guess. I mean, I'll wave my arms in the air and say it's from the first billion years of Martian history, and that's probably a safe guess. But until we bring some rocks back from Mars, it's going to be real hard to associate good dates with this stuff.
It's very interesting.
But in relative geologic time, this is a Noachian crater. It's part of the ancient cratered crust, and it's been eroded and then partially covered by these younger sulfate sandstones, the Burns Formation. The other thing I wanted to point out is that the beauty of the MSL discovery of the smectites in Yellowknife Bay and Glenelg is we have good geologic context. Right? We went to that particular spot because we thought it would be the distal end of an alluvial fan, the Peace fan, or some older fans that kind of coalesced. And that's where you find lake beds on Earth. That interpretation is holding up. Our problem with Matijevich Hill, it's not a problem, it's a great place, is we don't have that geologic context in the broader sense. And we only have a few meters vertical exposure of bedrock. For the most part, we were driving along what are called bedding planes. But when we get to Solander Point, it would be like stopping on an interstate where there's a huge vertical cut. Not vertical, but there's 50 meters worth of rock strata. And we'll be able to explore laterally and vertically, through geologic time and from place to place within one geologic time, and maybe try to reconstruct the actual depositional environment of these materials and whether they were lacustrine, that is formed by a lake, or fluvial or alluvial fan or whatever. We can't do that from Matijevich Hill and Cape York because the exposure isn't extensive enough. But my hope is by the time we get to Solander Point, that extensive exposure will allow us to do a lot more in terms of the overall geologic context. And I wouldn't be surprised that what we'll be looking at and have looked at in Matijevich Hill is an uplifted section of older crust that has a similar provenance to what we're seeing in MSL. But it remains to be seen with further exploration of the strata.
Yeah, there's actually a fascinating parallel between the two missions because over at Gale Crater, done a preliminary investigation on Yellowknife Bay, and now the rover's just about to pull up the anchor and head for Mount Sharp, where there's a lot of rocks piled up. And here we did a preliminary investigation at Matijevich Hill. We pulled up the anchor, and we're heading towards Solander Point, where there's a lot of rocks piled up.
Very good, thank you.
And in both cases, trying to travel expeditiously to get to the target.
Yeah.
Okay, lively discussion there. Let's go to our next question, which is from NBC News and Alan Boyle.
Oh, hi, thank you. I guess this question might be for John Callas. Just reflecting on the 10th anniversary and whether, I'm sure you never thought it would make it this far, but has there ever been any thought about, this has been going on so long, let's do something really dramatic, or do the recent results kind of prove that there's so much life left in opportunity that you're continuing with the step-by-step approach?
Well, I don't think there's anyone on this planet that would have imagined this rover lasting this long when we started almost 10 years ago. I remember when we got to the 5th anniversary that we were thinking, well, this is kind of be the last, sort of big hurrah event we would have because, who would think we'd get to 10? We're not there yet, but we just have a few months to go. In those 10 years, have we changed how we're using this rover? Well, because it's a rover and we keep traveling to new locations, we keep, reinventing this mission. We keep coming back to Sol 1 again. And we have all these exciting discoveries. I mean, with each of these craters we visited, it's been a whole new mission. And now that we're at Endeavour, which is, a much larger crater with much greater expanses of exposed geology and now much older terrain, Noachian terrain, it's like, NASA built a brand new rover and plopped it down in this new landing site location called Endeavour Crater, and we have a whole new mission again. And so we're treating it that way. But at the same time, we realize this rover's not going to last forever. and it could have a catastrophic failure, a massive stroke, if you will, and someday it may not be there. So we treat each day preciously, and we use it in that way.
Okay. All right, we've got quite a few of you waiting to ask questions.